Why is Antarctica, one of the most remote places on Earth, threatening to split in two? How did a crack buried beneath miles of ice become one of the biggest dangers to American cities? And when did this all begin? To understand the threat, we first have to go back in time. About 180 million years ago, Antarctica was the warm, forested heart of the supercontinent Gondwana, a world roamed by dinosaurs. But deep inside the planet, tectonic forces were pulling everything apart. Africa, South America, and Australia peeled away, leaving Antarctica all alone at the South Pole. It was during this continental divorce that something incredible happened. Around 43 million years ago, a new rift started to form, this time aiming to split Antarctica itself into two separate continents. It was a geological near miss. For 17 million years, the seafloor spread, pulling East and West Antarctica apart and stretching the crust by over 100 miles. The main evidence we have for this ancient failed separation is a deep underwater valley called the Adair Trough, a 140-mile-long scar on the seafloor. Think of the trough as the ghost of an extinct tectonic factory that shut down mid-production. If it had kept going, the world map would look dramatically different today. But then, for reasons scientists are still debating, it just stopped. The rift failed. The continent stayed in one piece, and the great wound in the Earth's crust was slowly buried under miles of ice as Antarctica fell into its long frozen slumber. This event, however, didn't just leave a scar. It created a fundamental weakness, a hidden vulnerability in the continent's very foundation. It's like building a skyscraper on a foundation that was cracked during construction. For a while, everything seems fine, but that hidden damage makes the whole structure vulnerable to future stress. This ancient weakness is now at the heart of our modern climate crisis. While the tectonic rift itself isn't active anymore, the damage was done. The West Antarctic Rift System created a landscape where huge parts of the continent's bedrock lie thousands of feet below sea level. This makes the ice sheet sitting on top of it, the West Antarctic ice sheet, uniquely vulnerable. Unlike the ice in East Antarctica, which rests mostly on high ground, much of the West is a marine-based ice sheet. A good way to think of it is less like an ice cube on a plate and more like an ice cube in a bowl that's already half full of water. This is where the story pivots from ancient geology to modern climate science. The real threat isn't the crack itself coming back to life. It's about how our warming planet is exploiting this ancient weakness. The main culprit? Warm ocean water. A current of relatively warm, salty water is getting pushed toward Antarctica by changing wind patterns. It acts like a stealthy submarine sneaking below the surface and attacking the ice sheet from its most vulnerable point, the bottom. It's not just lapping at the edges, it's flowing into those deep cavities created by the ancient rift and getting underneath the ice. This is especially dangerous at a place you've probably heard of, the Thwaites Glacier, better known as the Doomsday Glacier. Thwaites is a colossal river of ice the size of Great Britain, and it acts like a cork in a bottle for a huge section of the West Antarctic ice sheet. Crucially, it's grounded on bedrock that is not only below sea level but also slopes downward the further you go inland. Scientists call this a retrograde slope, and it's a recipe for runaway disaster. Imagine trying to pull a heavy doorstop off a ramp that gets steeper as you go. The further you pull it, the less friction there is, and the faster it wants to slide. That's the problem. As warm ocean water melts the base of the glacier, the grounding line, the point where the ice lifts off the rock, is forced to retreat down that ramp. On a retrograde slope, every inch of retreat exposes a thicker, deeper section of ice to warm water, which then speeds up the melting even more. It's a terrifying feedback loop, a one-way street toward collapse. The floating parts of these glaciers, known as ice shelves, are supposed to act as a buttress, holding back the ice flow. But these shelves are cracking and thinning. When they go, the glaciers behind them speed up, dumping even more ice into the ocean. The old geological rift created the perfect funnel, and now climate change is pouring warm water right into it. If you're finding this breakdown of our changing planet valuable, take a second to subscribe and hit that notification bell. Understanding these complex systems is the first step toward tackling them, and we have more deep dives on glaciers, climate tipping points, and Earth's hidden dynamics, just like this one, on the way. So, what does a collapsing glacier at the bottom of the world have to do with the United States? In a word, everything. The sheer amount of ice locked away in the West Antarctic ice sheet is so vast that its collapse would trigger a catastrophic rise in global sea levels. The Thwaites Glacier alone has enough ice to raise sea levels by over 2 feet. But remember, Thwaites is just the cork in the bottle. Its collapse could destabilize the rest of the West Antarctic ice sheet, which holds enough ice to raise global sea levels by more than 10 feet. A 10-foot rise in sea level wouldn't just be a problem, it would be a civilization-altering event. Major American cities would be erased. Take Florida. A huge portion of southern Florida would simply vanish. Miami, a city built on porous limestone, wouldn't stand a chance. A seawall would be as useless as trying to keep a sponge dry by building a wall around only one side of it. The water would just soak up from underneath. The Everglades, the Florida Keys, all gone, displacing millions. Up the coast, the picture is just as grim. New Orleans, much of which is already below sea level, would be indefensible. A huge part of Louisiana's coast would be swallowed up. Cities like Charleston, South Carolina, and Norfolk, Virginia, home to a critical naval base, would face devastating floods. Then there's the Northeast. With a 10-foot sea level rise, parts of New York City, including Lower Manhattan, would be underwater. Storm surges wouldn't be rare disasters, they'd be routine. On the West Coast, parts of Los Angeles and the San Francisco Bay Area would also be hit hard. And we can't forget Texas. The state's booming coastal hubs, Houston, Galveston, and Corpus Christi, would face unprecedented flooding. Houston, home to millions and a key hub for energy, space, and shipping, could see its infrastructure crippled. Port facilities, oil refineries, and entire neighborhoods could become uninhabitable. The Gulf Coast region as a whole would become a hotspot for repeated severe flooding events, turning today's 100-year storms into yearly disasters. This isn't just about losing land, it's about the cascading failure of society. It's like pulling a critical Jenga block from the tower of civilization. It means losing homes, ports, and infrastructure. It means saltwater poisoning our freshwater supplies. And it means the largest forced migration in American history. Entire communities would be displaced inland, triggering housing crises, food shortages, and economic instability on a scale we haven't seen in modern times. The quiet drama playing out on a frozen continent thousands of miles away has the very real power to drown the American dream. The story of Antarctica's underwater crack is really a tale of two different clocks. One is the slow, grinding clock of geological time that nearly split a continent, leaving behind a fatal flaw. The other is the frantic, accelerated clock of human-caused climate change, which is now exploiting that flaw with terrifying speed. While the tectonic rift is dormant, the threat it helped create is anything but. Doomsday Glacier isn't just a scary nickname. It's a scientific warning. Its fate and the fate of the entire West Antarctic ice sheet is tied directly to the heat we're adding to our oceans. And this isn't some distant future problem. It's unfolding now. Satellite data shows that West Antarctica is losing hundreds of billions of tons of ice each year. Grounding lines are retreating. Ice shelves are splintering, and deep marine channels beneath the ice are opening highways for warm water to invade further inland. We're seeing ancient systems unravel at speeds once thought impossible. The latest research continues to dial in the timeline, but the direction is clear. The ice is melting faster and faster. We are now watching, in real time, the possible beginning of a planetary reshaping. And it's not just the United States that's at risk. From Bangladesh to the Netherlands, from Pacific Island nations to coastal megacities like Tokyo and Lagos, the entire world stands on the edge of the same flood. But the future of cities like Miami, New Orleans, and New York isn't written in stone. It's being written in melting ice. The situation is dire, but it's not hopeless. The same science that warns us also empowers us with knowledge. Understanding the immense stakes, that a flaw on the most remote place on Earth could redraw the map of America, is the first step. The next steps are the choices we make right now to deal with the warming of our planet, because the water is rising.